good evening to one and all. Post yesterday's session, where we have discussed on the different aspects that are associated with life cycle assessment activities, and we have looked into the decarbonization challenges with respect to in a perspective of environmental engineering. The same way today, I'll be continuing that particular one with bit focus on how actually we do a life cycle assessment and what are the required data. So in the area of transportation sector, there is not much huge database that has been collected by our team, but specifically in the domain of waste management, we have started collecting less amount of data. So in that particular context, I have collected few data from the literature, which will be very helpful for me in explaining you this particular one. So today's topic would be mostly focusing on emission reduction and efficiency improvement. It is again from an environmental perspective. Like because a lot number of domains have to be included into this particular activity to come up with a strategy. So basically my viewpoint will be from an environmental perspective. So yesterday we have started the discussion with the same slide, asking why decarbonization, and now why emissions. So all the industries are very focused on scope 1, scope 2, scope 3 type of informations, which are direct and indirect from their processes from a full supply chain point of view. And there are a number of standards which are coming up in the reporting. And basically they report it to the government and they explain that we are reducing our emissions. And similarly, we are putting up multiple standards which are coming in. We're trying to do a lot of activities in our country as of now, and globally we are doing this particular one. But are we really projecting our emissions in an exact manner? Are we really showing them that we have a problem today? And certainly we'll come up with strategies which will reduce our emissions over a period of time. So typically this is greenwashing is happening, which is also budging up now. We have to look into that particular activity also. But overall in a process, from raw materials to the end of life, or when you're coming back to your utilization, recycling, reducing. So at each and every stage, we have emissions. And all the emissions, what we are speaking is mostly about anthropogenic emissions, which are man-made in nature. There are very few emissions which are biological in nature are considered in the LCA. But it is a simple example. On breathing, we release carbon dioxide. If I start considering that particular carbon dioxide in my life cycle assessment calculations, then I have to close my nose, and within minutes, what will happen, So biological emissions, the value that is inputted in the life cycle analysis is 0. So always it takes carbon cycle into the consideration. Any emission which is well fitted into that particular carbon cycle, the mother's nature's carbon cycle. So they are all considered to be 0, which are termed as biogenic or biological carbon emissions. All the emissions which are anthropogenic, which are man-made, which are increasing due to the activities that we are doing to meet our needs, are under this particular one, scope 1, scope 2, scope 3. Scope 1 is a direct emission where you can visualize from your boundary of your company or your house or your geographic location. Scope 2 and scope 3 are from the upstream and downstream processes. So where you have a lot of activities involved in that particular one. But to this particular workshop, we are focusing on the transport related. And you can see there are vehicles, transportation, and not both in scope 1, scope 2, scope 3, you can see all the emissions being reported over here. So how do we bring all these particular emissions, specifically from a transport sector point of view, is being discussed. So the greenhouse emissions from the transportation sector, if we see the pie chart, typically 22% come from transportation sector. And out of that particular 22%, LCVs and HCVs. So these two will contribute to almost 74%. So in the morning discussion in the circular economy approaches also we have seen concentrating on this particular 74% of emissions could be a very good component to reduce our carbon emissions and in turn contribute to the decarbonization also. So let's put up a question. After seeing this beautiful highways, we all wish to drive on a highway of this particular sort with a nice greenery in and around, with a nice road maintenance happening, So with a beautiful road where you can have a speed limit of almost 80 to 90, following that particular speed limits. So these are the pics from their India. These are not foreign countries. So have a nice location. And nowadays you can see from the past year 2012 till date, a lot number of highways are being constructed, expressways are being constructed to facilitate the mode of transportation. Whereas, and see, similarly within the cities, you can see the beautiful small cars, how beautifully they are traveling. So I'll go to the next picture. Same close look up of this particular with a lot of emission in it around. This pic is not from an Indian context. This is from a foreign context itself. Whereas the next pic is pollution. So we all have a question from our perspective that whether we want to travel in a beautiful green highway or in a most polluted highway. That is where the transition is happening. We can see the constructions are happening almost all across the country. And in the budget this year, we have seen a significant amount has been given to construction of highways. And as we have accepted for many years together that the transportation plays a role in connecting the societies, connecting the people, making our modes of life easy. So from a congested road where we stop continuously, where we generate huge amount of emissions, from to a very smooth highways when we are having. So there is a transition. So that's what in the past 2 sessions we have been speaking on. The vehicular emissions, different activities, policies that are to be taken place. But the emissions which are coming or which we are seeing are the direct emissions which are visible to us. But there are indirect emissions. One, from the construction phase, where all the highways are being constructed, to the maintenance phase, which we are unable to see those particular activities are considered as particular activities. So now it's very, very important for us to understand the complete transportation sector, see those particular segments from individual sector point of view, make it a direct emission and calculate those particular emissions. So at this point, I'll bring you the overall supply chain scenario of the transportation sector and give how the databases have to be developed, how impact assessments can be done, and interpretations has to be made of. So when I look at the system boundary from a complete supply chain point of view, production of materials, transportation of materials, work in progress, this is all for the construction and maintenance phase. Whereas the utilization phase is a well-known phase for us. Why? Because we have the vehicle, we use that particular one, we pay a lot of toll fees, etc. So anytime when you consider a system boundary of this particular sort and move on. And simple example of how it looks from a beautiful diagram to a technical component. So T is the transport that we are mentioning before opening to the traffic. That means the construction phase which we are having. So what are the raw materials that are required in the construction phase when you are looking stone, crude oil, then limestone, clay, all for preparing your required materials for constructing the road. And there is if there is an existing pavement, you mill it, which is called recycled asphalt you'll be using. So stone, there will be a crushing aggregate. The stone, once it is extracted, you have to consider mining, blasting, crushing, each and every activity that is associated with the stone. So, and once it has reached the crushing aggregate, so there is a transport associated in this particular one. So in the crude oil, the extraction and refining activities, which where you get the bitumen, again transportation is included. So then for preparation of the cement, we have a thumb rule that 1 ton of cement production will produce 1 ton of carbon dioxide. So that's why many alternatives are being verified in this particular domain also. That's a complete different picture that we're to discuss. But now let's look at this as a raw material. So then if there is an existing payment, you dig that particular one during the repair and rehabilitation and reuse that particular one. So nowadays, there is a concept called full depth reclamation, which is gaining importance in the Indian context. So they are instantly doing that particular grinding and immediately laying the complete road. So what is the variation between in situ full depth reclamation and laying a new road can be a very good study to understand. So once that is done, there are 2 modes, hot mixing and cold mixing, different methods of mixing in the of all these materials and paving the roads. So each and every stage has to be taken into the consideration. This is only a system boundary for road construction that is being considered. So one such way you can consider the boundaries for utilization phase, maintenance phase, the full sector from construction to the maintenance phase. So that's the boundaries for like cradle to grave, cradle to cradle, where from you use the raw materials, then processed them, laid a road, from then you have used that particular road, then the complete flexible payment has come to a maintenance stage. Then you have grilled it using full depth reclamation stage, and recycled asphalt which has been collected has been used for laying that particular road. That means you are avoiding all the upstream steps. The raw material extraction, processing, all were excluded. That means avoidance of the has been taken over here. So such sort of cases can be considered. And even in your goal and scope, when you are considering over here the business as usual scenario, where you are putting up a new layer with virgin material, can be considered as a business as usual. And in the next scenario, which it can be a very hypothetical scenario, and you can assume that I'll use very, very high efficient materials which have been produced from chemicals, all those, and I'll lay them. So just come up with different ideas with hypothetical situations, with possible situations, which can be very innovative after 20 to 25 years, which can be implemented. But once we start comparing all these particular scenarios, we'll have a very, very good interpretation. So goal and scope plays a very major role when you are working on that particular activity. Post that, the key important one is the assumptions. You consider a functional unit, assume different components which are required for that particular one. If any data is missing, try to take it from literature and make it as an assumption. So list out all the assumptions. These are some example assumptions that we can make. Has been written. 100-kilometer lead distance is assumed for construction materials. So basically, the industry people can very nicely understand when they are on the field. The lead distances vary a lot from location to the location. So how do I consider this particular lead distance into my LCA study? So make up an assumption that 100 kilometers. And once the complete study has been completed, once you have run the LCA, then you can vary this particular 100 kilometer from 50 to 5,000, or whatever distance we can use. Why I say 5,000 is, if you are taking an air transport or a water transport, yeah, your miles will come into the picture, so the distances will increase. So the mode of transportation can be changed, the distances can be varied, different types of material can be varied. So you have to consider each and every component over here, and any missing data, just use the available assumptions, use mathematical calculations, do theoretical calculations, put them that I have used using a theoretical calculation. We'll see an example, how do we do that particular one. And next important, once you made all these particular assumptions, life cycle inventory creation or database development is the key component. So here we can see the first component that you have to see is, suppose here I'm considering the 3 phases: road construction, road operation, which is the utilization phase, and road maintenance. So prepare a table of this particular sort. This is the ADB, Asian Development Bank methodology for calculating the carbon footprints for the different road projects in the Indian context. This is the complete example what I'm giving has been taken from that particular report. So there are different segments that we can consider. In the construction phase, the embodied carbon which is there associated with the construction materials, whether you are considering it or not. Yes. If no, just explain, just say that I'm not considering that particular one. Then we use fossil fuels, embodied carbon associated with that particular one, which will come into the scope 2 and 3, whereas the direct CO2 emissions, which are from the vehicles, from the direct activities, where you can calculate whether you're considering them or not. Then removal of vegetation. So one very beautiful activity that we have in this mother nature is the greenery, which is balancing our activity. The carbon dioxide's biggest sink is the ocean. We are going towards the ocean as acidification now. That's a different scenario associated with our greenhouse gas emissions. So, but trees also play a very major role, both in maintaining our payments in the maintenance activity by reducing the temperatures that are increasing, and similarly, it gives thermal comfort to the people. So trees plays a very, very major role, whether you're putting a direct trees or indirect with the lower locations when we are growing. So all has to be considered. And in any certain component of deforestation. So certainly we will lose certain number of trees. So whether you are considering that particular activity, removal of vegetation, where carbons, if you are planting some additional number of trees under the term of environmental management plan, so you add that particular one which will contribute to sequestering of the carbon. So that is what carbon sequestration potential, which is lost, has to be considered here. And in your interpretations, you have to present the environmental management plan for getting that particular sequestration back again. And the direct CO2 emissions which are lost due to the vegetation health, whether they are considered or not. And similarly, machinery and vehicle, the equipment, one general statement we always try to use in our LCA is we are not considering in the equipment manufacturing. That means the capital goods which we are using, we don't consider those particular one. In the yesterday's presentation, we have seen almost out of 108 studies, we haven't found none have considered the capital goods. So which is one of the key critical areas, where because in 2007 there is a report which is published that 2 to 3% of the carbon emissions come from the capital goods, and that vary from project to the project. So it is very, very important whether we are considering the machineries as well as the capital goods that we are using. So this is common for all the three phases in the construction, operation, and maintenance. So in any study report, you have to mention what are the considerations that you are doing, whether they are being included or not. Post that particular one, I'm showing you a list of template to collect different components in the construction phase. So on-site electricity and fuel usage, where you can, we'll see that electricity purchased from the grid, that will be taken from your energy meters. So in every location we have a unit installed. We consume power and we pay bills every month. The same way at your locations, what is the amount of energy that your electricity that you are consuming can be calculated. If you can install the energy meters at every location, possible location, from if one unit process to other unit process, if you are changing, if you are able to install the energy meters, simply like voltmeter and ammeter, and do the calculations, that will be very grateful. So that you can develop a system or develop a strategy to reduce the energy consumption exactly at that particular location. And similarly, we have seen in the mission life goals to stop lights, to use less number of like switch off all your motorbike activities during the signal. Small activities you can use, which get contributed in the utilization phase. So each and every activity what we are doing to incorporate them all into the life cycle assessment is not an overnight job. It takes huge amount of time. So we have seen, that's what we are learning from the past two sessions, that how much time is required to calculate, how do we include, how many factors are included into that particular activity. So prioritize what are the major factors, so that we can reduce 20% of our emissions, 30% of our emissions, 50% of our emissions, achievable goals. Let in a policy making, if I say I'll reduce 20% of my goals by 2030, 50% of my goals, my emissions by 2050. So put up an achievable goal. Write some strategies which for the short-term goal and long-term goal. Suppose I'm writing a strategy now. So by 2026, what I will achieve. By 28, what I will achieve. By 30, what I will achieve. Write three sort of goals and see whether I'm achieving that or not. If I'm not achieving, let me change my action plan over there and put up an achievable goal over there. So that helps in putting up the right amount into the right pocket to go towards decarbonization. So diesel used in generators, diesel used by friction machinery, in vehicles, petrol use. So each and every component has to be taken. When you are start up with a small project. Don't try to achieve very high over there. So take up 1 kilometer stretch, write out all the activities which are there, then move on to the 10-kilometer stretch. Why? Because 50% of your data is ready. When you start increasing your project, then small factors will come into the picture. A laboratory scale experiment moving to a pilot scale, pilot scale to an industrial scale. In a laboratory scale, we'll have a simple energy input being given to my system alone. Once when we move to the pilot scale, there are additional components added where you have to give an electricity. But when it goes to an industrial scale, even for your rooms where you are staying, there might be an AC. So you have to consider that particular activities where the personalized activities, not alone the processing. So all these big activities will come into the picture when you are going into an industrial scale. That's why LCA, we prefer to do it in an industrial scale compared to a laboratory scale or at a pilot scale. At a research level or an academic level, it is always accepted to make assumptions and say how we are shifting to an industrial scale, put those particular assumptions and conduct a life cycle assessment. And from an industrial scale or the government scale, do with the real-time projects, collect all the data from that particular one, develop the inventory databases, and start the projects. So all the reports which are there, they are done conducted with the real-time data that is available from the national highway projects. And similarly, the vegetation that has been removed, biomass used as fuel wood. So fuel wood in kgs, you'll be calculating the emission factor will be in kg carbon dioxide per kg. Similarly, now it is like fuel used in transportation of the materials. Even in the construction phase, we transport lot of materials over here. So all those particular activities with your lead distances, you calculate in the free load. How much amount of tons that you are transporting, you will be converting them, you'll calculate. And the embodied carbon in the construction materials, slowly consider them, and fuels that you have used will be considered. And same, when you look at your operational phase, you have to consider different types of vehicles that are being there. What is the fuel type? What are the emissions that are coming out? So the data inventory basis that are explained by Dr. Sarath can be a very valuable input over here. And similarly, the embedded carbon in fuels, there is like petrol, diesel, LPG, which is common, which has to be considered in the construction phase also, is to be considered over here. And then from the maintenance phase, so different construction materials, almost similar to your construction phase will be there. Materials, fuels, any fuel used on site has to be used, and fuels used in transportation also be considered. And the same if you are using the VAP material, recycled asphalt with the full depth reclamation technology. So it is an in situ, which means the on site. So you have to develop your boundary. This shows an example template sheet for your complete project. Now I'll show you an Excel sheet here. So how do you develop an inventory database? So how an Excel that we develop will look like. So yesterday we have been looking into different unit processes. This is for material trialing for it's like coal washing activity that they are doing. So this is a simple example from one of my lab mates in the Cotton University, their project work. So this one, in order to generate 1 ton of carbon from flotation overflow. So in this particular activity, they have developed one. So you write each and every unit process. So in that particular one, you will supply certain X amount of fine coal, where segregation fine coal by using column flotation has been considered. So that process is the first unit process. Then mechanical dewatering. So by using thickener, it is considered. So let me increase the size so that it will be more visible. So post that first mechanical dewatering, second dewatering is by belt process. So post this particular stage, there is a transportation of tilings to the disposal, and finally it is dumped in a landfill. So this is a step-by-step unit process. So where do I get all this particular data from? So how do I collect all this particular data? So certainly, being an domain experts or people researchers working in a separate domain. So I don't know how this manufacturing activities are happening, how this particular processes are happening. So it is very difficult for me to understand. So because I have never understood that process, I've never read that particular process. So when we wish to do an LCA in this particular sector, we should have minimum basic knowledge in this. So we do a field visit initially. So go to that particular field, start speaking with the people, and take out the literature, start understanding this particular process. So once you understand what is segregation of fine coal using column flotation, so you'll sit with different experts in that particular industry and with academic experts, and will start sorting out what are the inventory data that you require for this particular unit process. The input output mass balance diagram has to be developed, both in for the energy, for material. You have to do that particular. Then go for mechanical dewatering by using thicker. So what does this particular unit process mean? So when you're visiting an industry, you can clearly see the process, how it is working, and make your notes all the time. So that is very, very, very important when you go and visit an industry or there. Suppose very simple example is when you start watching the road transport sector, the transportation people will do a survey. So how many number of cars are passing from morning till evening? This will be a transport vehicle survey. So the people will be sitting on that particular road at a given junction. So they from morning 10 o'clock to evening 5 o'clock, if they are doing 10 to 11, how many vehicles have passed in that particular road? So what is the type of vehicle? A vehicle survey will be done. So there are different ways of doing that particular vehicle surveys. The same way, if you just see, you go to the industry, start understanding what are the different methods that they are doing. So mechanical dewatering by one process, mechanical dewatering by a second process. So once you come back, if you're doing specifically for that particular industry, do LCA. But if you are an academic expert, consider different alternative scenarios and do a comparative study, which will be helpful. And then go on to the transportation, consider all the transportation activities. And every sector, the transportation is included. That's why we are mostly speaking on this transportation decarbonization, which will help a lot in reducing our global emissions. And finally, the landfill, consider all the landfill models, all the equipments which are doing, and calculate it. So once you have identified each and every component over here, so I'll go to the initial phase. There will be write down what are the inputs, coal properties, the chemical properties of the coal by conducting different laboratory experiments are considered. The material which is that's considered, energy, chemicals. So each and every component has been calculated over here. And what is being inputted, we have given it with a coding number, and see the references for each and every component. So this will help us a lot when we are doing our interpretation. So because this will take minimum 4 to 5 months for preparing an inventory, then running the impact assessment, verifying it, it may take 1 or 2 months more. And almost till after 8 or 9 months time, with all the personal and professional activities which we are having, the thought process which we have, the knowledge that we have gained in the field visit at that particular time might have volatilized. So this particular sort of tabling will certainly give us a good input so that we can come back and remember from our notes as well as from these references. And this is with the input and this is with the output. So each which designation I'm giving, where is that particular code going? So mention all these data. So same way, there are different options that are there. So for each option, the data has been developed. So there are different options, and there are technical interventions that we have made in the comparison of materials. So all this is the impact assessment which comes, but we are not interested in this particular one as of now. So let's go back to our activity. So once you have done that particular complete activity, so once you understood what is the inventory database that you exactly want to develop, so do an iterations multiple times, visit the industry or visit your site multiple times, read the DPRs. So do an extensive literature survey. Whatever data is directly collected is your primary data. If any missing data, make assumptions, use theoretical calculations, use secondary data reports, develop your complete inventory database. It is very, very important. It is the heart of life cycle assessment. And so once that data has been developed, you can do impact assessment. Prior to that, I'll show you the examples on this. What is for their calculations in the different road projects, what are the data that they have collected. Electricity and fuels used on-site and vegetation that has been removed has been considered. So the data which you are seeing over here is typically the real-time data that has been collected from the road projects, national highway projects in the Indian context. So next is the construction materials used per kilometer. So this per kilometer is the functional unit for considering all this. So there might be different roads. One road has been constructed for 100 kilometers, one road for 50 kilometers, one road for 25 kilometers. So there might be variation within the kilometers, and all the project DPRs will have the quantities for that particular amount of road. Like for 25 kilometer stretch, what is the bill of quantities I'm having? And none of the projects will have a readily available inventory database for doing a life cycle assessment, because it is not that easy for the non-expertised person or a field person to start understanding that someone will come and do a life cycle assessment for me, so I'll give that. So they're very much focused on executing the project. The goal and scope for the other person is different, and the goal and scope for me is different. So I should go and explain them, collect the data which I want, and convert them in the way I want. So I'll use a per kilometer as a functional unit for collecting the data. So I'll get all the bill of quantities or estimations that have been readily available from the detailed project reports, and I'll put them into my Excel sheets and convert. A simple conversion can make a unified value for us. So that's what this table is showing. So for every kilometer, what is the amount of material that has been used? So metric ton per kilometer, metric ton per kilometer. You can see individual is like commonized functional unit. Same, the amount of diesel that has been used, kiloliters that has been used for the transportation of construction materials. And post this in the operation phase. Until now, what we have seen is in the construction phase. So in the operation phase, for each different type of vehicle that they have considered over here, and post model share. So I said traffic survey, which you do, what is the type of vehicle that is going on in that particular road for a period of 1 week or more. If you can do that, would be very good, because as the average increases, the possibility for doing an uncertainty analysis will increase. So the more the data, more accuracy will be my results. So conduct a model share and find out what are the different types of vehicles that are going, and connect all the necessary databases to this particular one. And then in the maintenance phase also, you have construction materials and fuels. Same for metric ton for 1 kilometer, consider all these materials. So once you have finished this particular activity, the next important activity will be the life cycle impact assessment. So your heart is ready now. So now you just pump your blood. So comfortably do all the activities with your heart. Processing will be there. How do you do it? You can do it in any way. The natural way of working with the heart. Replace the heart with a different heart. Put up stunts to improve their activity. So any way you do. So a simple calculation which I am showing, so that you can do with a manual calculation using an Excel sheet, write a program, or if you have data, good access to your different softwares like Sima Pro, there are Greet model, Greet, Fleet. So there are many softwares which are available. You can use softwares, but however, the recommendation would be you can develop your own model. You can develop your own model with the advent of Python programming, different languages. So you can prepare your own optimization models from this particular one. So do collaborations with those particular people, tell what are your constraints, and develop your own models. The most preferential activity will be developing your own model. So that is where the possibility will be there. From your discussion, typically what is the highest prioritized parameter can be considered. For example, in the previous session, we have seen that lead is not considered in their emissions list. They're where your matters. So you're able to hear, sir? Hello. So slowly you can add one by one component all the time. It's like very simple example I can say from the point of view of a research scholar is a single research scholar cannot solve all the problems. That's what the biggest lesson from my PhD work. So it is the guide who does a very big project for 10 to 15 years, and part by part will be solved. After 15 to 20 years, you will get the final outputs. It is very simple. Like the professor who gets a Nobel Prize will have a very good big bench with almost 200 like 150 to 200 people working across for past 25 to 30 years. The BTech students, master students, PhD scholars, collaborations, everyone, all these people's contributions were comprised into one component. He gets a Nobel Prize. The same way, so we should start thinking that developing an LCA model, giving this particular one as our Nobel Prize. That's what the contribution that I am doing. So slowly I'll collaborate with different people, start working with them and make one component included. And so on the day one, you might have 10 parameters. On next year, 15 parameters. After 10 years, you may have included 150 or 200 parameters, where your model is very, very, very accurate now. And the changes that are coming in the technology can be included. The changes that are coming with the geographic locations will be included. Seasonal variations can be included. So I don't see the variation of seasons over here. So this is a very limited one, which says that 70% of the emissions can be controlled by using this particular one. So choose a model of this particular sort. That's why I'm not giving a full picture of what life cycle impact assessment is. It is left to your choice. You can model it in any way. You can do a simple carbon footprint calculation and take a decision making over here. So as I go on from linear to non-linear regression modeling and multiple impacts into that particular one, complexity increasing into that particular one, it will be more and more beautiful. So start from the basic, go into deep down, so that the complete impact assessment can be done. A full amount of picture can be received. But a simple example which I will give you here is every year IPCC report will release carbon dioxide emission factors. So to decide the carbon dioxide emission factors with respect to the other greenhouse gases, yes, so they require the complete data from the whole world. So sitting in a European continent, they get collaborated with all the 196 countries, and all the 196, suppose they contacted India. From India, we have all the city calculations that we are doing. So all the data which has been collected will be reported as a single value from India to that particular location. So they receive 196 data reports with a huge amount of appendixes which are there, where they put into their model calculations and finally come out with one value saying one. It's like carbon dioxide impact will be 1, whereas carbon monoxide impact compared to the carbon dioxide is 28 times now, which is increasing to 29. Expected by 24, by 24 reports, certainly it will go to 30 is what the assumption, and it may increase with the anthropogenic activity we are having. But whereas in the 2016, when we have started working on this, it is only 25 times impactful. But the change has come within 5 to 6 years. Like 28 is by the year 2021, we have heard that it has increased to 28. See the rapid increase that is happening. Same way, if you see NOx, it is almost 183 times more impactful than the carbon dioxide, which is increasing now. And similarly, SOx is around 200 to 250 times. So all these emission factors are very, very important for calculations. So in getting one single value is very, very, very important, and putting up a hard work behind that particular one is triple times or 100 times important in getting there. So reproducibility, repeatability, validation plays a very, very major role when I come to my impact assessment. So the inventory database plays a very, very important role. So these are the outcomes from that particular project, from the different projects for a given road length, which I told you the road length varies. That's why you are seeing the amount of material which are consuming is also getting varied. And within the time period, so the actual time periods have been taken from the date of start of the project to the end of the projects were considered. And the design lives have been considered, and the maintenance periods were considered over here for the each phase. So overall, in the each case, the total carbon dioxide impacts have been calculated, and you can see the different activity which is happening over here. So once you get this particular results, what is my typical activity that I do? Typical activity that I'll do with this particular result. But because you just put in a software, you just take it in from a what would I call from an Excel sheet. You input any sort of data, you will immediately get a result over here. So is my result very accurate? Is my result, how do I validate it? So that is where my life cycle interpretation comes into the picture. So in the completeness check, you have pedigree trees readily available for this particular one. So you use that particular trees where you can the pedigree tree where you'll check with geographical scope, technical scope, different scopes that you'll have, and you validate your particular data. And sensitivity checks, as I said, transportation distance is a very sensitivity parameter. Electricity is a very sensitive parameter. So make an assumption over there. In our assumption, we have made 100 kilometers as the transportation distance. So you vary that particular one from 0 kilometers to 5,000 kilometers based on your transportation mode and get a range. So now you can apply it for the project. And finally, as in the yesterday's sessions also, Professor Dubey has discussed that there is a dire need for the people to develop a significant software and interface where people can input this particular sort of data and understand how much amount of impact they are doing for decision making. Typically, it is mostly for product development, EPD declaration, strategic planning, public policy making, marketing. So that is very important. So once you have this much amount of data that is there, the interfaces can be developed. So that's the end of the session. So it is very, very important during the interpretation. So before finalizing this particular one, once you complete the complete LCA, what sort of interventions that you can take over is what we will to look in. So the interventions that can be come out as like the long-term roadmap improvement that what we can do can be interpreted from the LCA. Then implementation and enforcement of mechanisms based on our set goals can be implemented. Suppose by 2030 we want to achieve something, 2070 we want to achieve something. So what could be my enforcement mechanism? What could be my implementation mechanism can be drawn out. Similarly, how how tighten I should do my with my existing norms. Whether I should change the existing policy norm regulation. So should I stringent that particular one has to be taken into care. And you can look into the different options like alternative fuels, which is the scope of our project. So you will verify all those particular aspects and then you will try to implement it. And in the last session, we have seen different alternative fuel options with electric vehicle, gasoline plus renewable, electric plus renewable. So what will be a good scenario with in the 2030 scenario, 2050 scenario, how they vary with respect to different countries. Also we have looked into yesterday, and different modes of transport, rail mode and road mode. What are the different strategies that are to be implemented or also discussed, like modal shift, electrification, and then transport planning, alternative fuels. What could be the possible reduction in our emissions? But discuss. So you can take a decision which type of fuel that you have to use. And similarly, the technological interventions are to be made and made very critically in this particular modes. So which technology can become a very better activity. And for a country like India with a very diversified cultures, diversified systems, diversified climatic conditions, diversified road populations, mixed vehicle traffics. So what could be a scenario can also be developed. This would be a small scope that provides all the researchers, scholars who are present, academicians, industrialists to start thinking of in developing the databases for life cycle assessment, for doing a better sustainable strategic planning. So thank you. So take questions. Oh. Thank you, Ravi. And can you highlight on the basic difference between attributional and consequential LCA, and which type of LCA can be chosen based on the requirement? Okay. So that name in this particular one, the attributional and consequential name itself is suggesting that particular one. So attributional is for a full length life cycle assessment. If you are doing a standalone LCA, suppose from cradle to grave for a road activity, when I am doing an attributional LCA. What are my attributes? What would be its problems associated with it? Is what's a simple calculation I'll be doing in the attributional one. Consequence, by implementing some activity, what is the issue, or will it be more environmental friendly, or will it be emission causing to the environment? So if I'm trying to look at the consequence of an activity, suppose simple example now, what is the impact associated with the diesel cars? diesel cars, if I am studying, that will be an attributional one. So now if I am introducing a hybrid car into that particular one, what would be the variation in the impact? So here the road will remain same. The production of vehicle will remain same. The materials which are required to the production will remain same. So there is a small variation that is going to come is in the hybrid vehicle, you are adding an EV unit. The battery is being included. So whereas in the IC engine, there is no battery. So introduction of this particular battery, how it is going to impact. So I'll see the supply chain of the battery vehicle from raw material to the disposal. I'll include that particular. So additional to the existing one. So what is the consequence that is being done by adding a hybrid vehicle? Now electric vehicle we are considering, then hydrogen vehicle. So what are the consequences of including these particular activities? We'll do a consequential LCA. Mostly the comparative studies will be a consequential ones because you do. But if your functional scope is to understand the consequence of a problem, you go with a consequential one. So if it is not the one, if you wish to calculate the overall ones, it will be mostly attributional. But as of now, with the advent, this attributional and consequential has been moved to aggregated value or a single value. So in aggregated value, when you will consider the complete system, whereas in the single unit value, you will be considering specific components which cause mostly 70 to the 80%. So all the SimaPro softwares and Gabi, whichever, all the eco-invent are now shifting to this particular one. So that I hope this has answered the question. So any other questions? Which LCA softwares can I use to carry out LCA of electric vehicles? Any software. If you have data, basically SimaPro software is a generalized software. So specifically, it is not for a specific product, just like GREET, which is very specific to the electric vehicle, which is specific to the transportation, which specifically designed for that particular one. Similarly, EaseTech is a specific software for environmental engineering, specific to solid waste management. Gabi, OpenLCA, SimaPro, all these are common softwares where you can use. And similarly, you can develop your own software also. That I would prefer you to develop your own calculations, your own software, or if you have sufficient amount of inventory data, you can go initially with SimaPro, Gabi, or any specific software. So it is not the software which is going to play the role. It is the inventory database that you are developing, how you are developing your model. So we have to understand behind architecture of the software. So very simple. Most of the time we'll be using CML method or recipe method. Right. So how does this particular recipe method has been developed? By including what parameters, what are the end outputs it is going to give? Because in most of the studies we have seen like 15 to 20% of error variation have come in few projects, and we have less than 5% of the error coming in our LCA projects when we use different models. If the error in the results by using different impact methods is less, then any method will solve the or give us the results. But if the error is more, again we have to reinvestigate on why the error is more, what parameters that they have considered. As I have shown you in the equation, let me share my screen once again. 1 second, I'll share the screen. So this is the value you are seeing. So what is the emission factor that they have considered? So how they have calculated this particular one, I can show you the yesterday's PowerPoint presentation also. That gives a very insightful activity on calculating. So here you can see how do we calculate the impact. So first is the material transfer database, that's the inventory database. Then the process exchanges data. and I'll be calculating the characterized impact in this particular different layers. So the flow layer which I am having will be calculating all my material properties, the unit processes which I am doing. Then I'll multiply them with the elementary exchanges, and finally with the impact categories which I'm calling. The characterization factors will be multiplied over here. So that's how I get a final output for my impact assessment. So to conduct this particular one, we are developing a tool. So whether it is an Excel tool, whether it is a system-based tool, whether it is an optimized tool with a advanced language, it depends upon us. And the validating and doing that will give the accuracy. So it's not the software that plays a major role. It is the way that we understand the process. So thank you. So I'll just escape. So then Rajarshi, thus adopting a system expansion and substitution approach for impact allocation makes it a consequential approach. Yes, 100%. Because there is an existing one, I am adding a new component, So when you expand that particular activity, so you are not giving an output after the expansion. Very, very simple example that would I take is, so suppose I have an industry. So now for a certain processing, I have already done the LCA 3 years back. Now I am expanding my production unit. So what would be the impact if I expand this particular production unit? So that is a consequence which I am getting. So whereas for impact allocation, this is a complete different picture. Impact allocation comes in the inventory part itself. So it is as simple as, like, suppose I am producing an X crop for producing biodiesel. So, but suppose that particular crop is a cashew one. So the cashew will be used for food purpose, and as X percentage of crop is being used for food purpose, and Y percent is being used for my biodiesel production. That is where the allocation comes into the picture. So once, if you are adding anything to that particular allocation, suppose I have 70% for food and 30% for biodiesel production. Suppose that has been changed from 60 to 40. Certainly you are changing that particular case. You haven't compared it. After 10 years, you have increased this particular one. So what would be the consequence of changing this particular one? So it is a consequential consequence activity. So, but the initial one which you have done is an attributional one. So that's the variation. The next question is, does the value of characterization factor varies with reason? If so, do we have Indian specific calculation basis and factors? Yes, it varies from reason to reason. That's the reason, if you can look into the different impact categories that are being developed, they'll say European value, world value. So certainly it will impact. Indian specific calculations, that is where there is a need for us to join hand in hand and develop all the calculations, to do calculations and develop the factors for Indian specific context. To my knowledge, as on date, there are no emission factors developed. Specifically for electricity, now the CIMA-Pro has given few emission factors specific to that particular one. Specifically for the climate change energy sector, the IEA, International Energy Agency, is working on this particular one. So there are few, IPCC, which is working, has developed few emission factors, and few of the industries are working. There are few emission factors, but not very specific to each and every one, like how European people have developed, India doesn't have. Oh, connecting question, how do we go about developing these factors? We want many people, climatologists, physicists, atmospheric people, air quality people from environmental engineering, we environmental people, everyone should come hand in hand, develop the waste database, the data, mostly since I work in the waste management scenario, waste database will come. So specific that particular domain database you develop. For simple example, in the last 2 sessions, we have seen Dr. Sharath Ji was developing in his own databases and data sets. So you collect that particular data set and prepare a value. Very simple example, we develop water quality index. So we conduct different tests and develop a index by developing different graphs. So for which we do conduct lot of field level investigation. Same way we have to do that particular one. And for example, again, from the air quality point of view, we have different centers, different collection points, analyzing points located by CPCB, which collects all this particular data and provides a single unit value for India. The same way, huge funding is required, huge amount of man force is required, a lot of collaborations are required between industry, institution, and government, and especially huge amount of data is required, and thought process is required. Capacity building is required. There are a number of factors if I start going on listing them. So we are making way into that particular direction. India is progressing in that particular direction. Hopefully, we accelerate our system to do this particular value by 2030, or by, I am 100% sure by 2046, the time I retire, I'll certainly see this particular values. All the questions become realistic in Indian context. Oh. Yeah, Ashri Boran, do we have emission factors for different electricity mix in the Indian scenario? This I have to look in. The recent databases that are available with EcoInvent, I didn't go through them. But previously there is no. Previously there used to be a single emission impact factor value. But most probably for the full country, the Ministry of New and Renewable Resources are generalizing the what energy mix for us. So we'll have a single emission factor for that. But the new CIMAPRO inventory database has 6 segments. For the each segment, whether they're giving or not, I have to verify. So I am at the neutral stage. I can't answer this particular one as of now. But yes, they may develop that particular one. So we can calculate it. So any other questions, queries, or points of for developing? If there are no questions, then we can close today's session. Okay, then. So that's the end of our day 2. So we are thankful to all the participants who have participated from the day morning today. So this will be a very insightful session from Professor Brajesh and Professor Sharath for us. And tomorrow we have Professor Krishna Biligiri speaking on the different aspects of circularity. And then we have Anush who will be speaking on the case study associated with the payments. Then we have Professor Uday Shankar who will be discussing on the transport policy aspects and everything. So we'll end the session for today, and we expect you all to join for tomorrow's discussion. So bye, and have a nice energizing session to the night. Thank you.